welcome back to AI Vantage Point. I'm Bradley. In my previous video, I've just demonstrated image to video and text to video capabilities of the ltx2 model. Today we're gonna dive into another capability of this model, which is controlnet. Today we're gonna use this workflow to animate this image using this reference video. Before we dive into the workflow, we should take care of some prerequisites, and the first one is the models. In my previous video, I've covered a lot of these models. I've covered the video and audio VAE, the upscaler, and the main gguf model. Today we're gonna need two extra models. The first one is the dwpose, is the main character of today's video, and the other model is the gguf version of Gemma 3. And I will leave download links to these two models in the video description area. Once you've downloaded the LoRa model, you should put the model in here. It's in comfyui zluda models LoRa and ltx2. Put the downloaded file here. As for the text encoders, you can put the downloaded file here. Actually, there are two files that are needed to be downloaded. The first one is the gguf main model, and the other one is the tokenizer. I will leave the links in the description area. Okay, and the next prerequisite is you should generate the first frame of the generated model, and the gestures should be conformed to the first frame of the reference video. If you don't do this, there will be a very drastic gesture change. That is not what we want. Okay, that's all prerequisites of today's workflow, and we'll move on to the detailed groups of this workflow. The first group is load model. There is actually nothing to say about this. And the second group is the prompt. As usual, I use the llama cpp instruct to reverse engineer the images. The model loads images and describe about images, and using the ltx2 official guidelines to generate a positive prompt, which is very friendly to this model. And after the prompt is generated, Gemma 3 text encoder will be used to generate the conditions, and that's the prompt group. And the next group is controlnet pre-process. Actually, we use this dwpose estimator to extract the hand, body, and face information from the video. And then the dwpose information is merged into an empty video latent using this ltx add guide node. And an empty latent audio will be generated, and after that, the video latent and audio latent will be concatenated. And after that, the latent will be fed into this stage 1 sampler stage. This stage is just as the previous video. There is nothing to say about this. But the difference is I saved an intermediate result here. Because the ltx2 model add the dwpose information to the end of the empty latent and generate the video along the way. So I use this split images to split the end result into two sections. The second section will be cast out, and the first section will be preserved and to generate this video. And this is the end result of the dwpose skeleton information. And after stage 1, the resulting latent will be fed into this node. the ltx2 cropwise. Actually, this node just did the same thing I do here. They just cut out the second part of this video latent and preserve the first one. Then the latent will be fed into this node. What this node do is actually it preserve the first frame of this generated video. It will not be generated. It will be marked as generated by this code. Here I add a markdown note to actually explain the functions of this node. You can actually see this, and if you have any questions according to this node, about this node, you can leave a comment in the comment area. I will answer it as soon as possible. And then the first frame will be added. See, this frame is loaded from the input, and the frame will be added to the latent, and then the latent will be fed into the second stage, which is the upsampler stage of the workflow. And actually the sampler didn't change much as in my first video, so I won't talk about this. And after the sampling, the end result will be fed into the output, and the video latent and audio latent will be decoded separately. Because I don't use the soundtrack generated by the ltx2 model, I just use the original soundtrack, so I just save it in an MP3 file. The end result will use the original soundtrack, and this is the end result. As you can see, there are problems here. In the intermediate result, you can see the end video conforms to the dwpose gestures very well, but in the second stage, after the upsampling, actually the gestures won't conform to the dwpose, because the second stage not only upscale the image, the video, it also smooths out the gestures. In the official IC LoRa tutorials, you can see actually the tutorial has used the medium shot reference video, and the actions isn't that quick. See? It's very slow, and it is in medium shot. But in my demonstration, I use a wide shot reference video, and the movement of the characters is very quick. So I think the ltx2 model is very good at processing medium shot and slow motion. As for wide shot and quick motion, actually the model doesn't perform very well. So I've come up with a solution. Actually the solution is very straightforward. It actually doesn't use the stage 2 upscaling. It just uses the stage 1, and we don't downscale the image. We don't downscale the video latent, and we actually use the upscaled one. We use 640p, so we can get a very good result. See, that's the end result of this video. Without using the stage 2, the gestures is preserved, and with upscaling the resolution, the end result will be very good. As you can see, we're in the process of video generation using this workflow. In my first try, I've generated a 5-second video, which cost me about 49 minutes. In the second try, which is this one, I've generated a 6-second video. Because I want to completely cuts out the last 3 frames. If you use a 5-second video, as you can see there are 3 transition frames. If you use a 5-second generation, the last 3 frames will be lost. If you use a 6-second generation, you can cut out the last second completely, which will result a very clean video generation. So I will give this a shot and see if we can get a better result. I will pause the video here to wait for the completion of this workflow. Okay, the workflow has completed. It cost me about 1 hour and 2 minutes. And here is the end result. I think it's pretty clean compared to this. And there are some glitches in the facial area. I think that's the limitation of the model, because the movement is really too quick. You can use upscalers like vram2 to do some corrections and also upscale the resolution. It is up to you. And this wraps up today's video. If you like my video, please like and subscribe. If you have any questions, please leave a comment below. I will answer as soon as possible. Thanks for watching and see you next time.